So today I'm going to go through Quicksort. I'm going to go through a little bit different way than how other videos do it, because there's a lot of videos that do Quicksort, and generally they show kind of intuition and then the code. But instead, we're just going to show the code first, and then kind of reenact the code in the paper app on 53. So you can see on the right here we have how to do Quicksort in Swift, and I'm just going to put out a random array, and then we'll kind of step through it as if we're the code. So let's say our array is 100, 40, 0, 3, 2, and 9. Okay, so that's an array that we pass into Quicksort, and we're going to start down here with the initial call to the traverse function. So we need to set up a bunch of different pointers. The first is going to be kind of the start pointer, which I'll mark with yellow. I'll make a little key here. This is start. Yellow is start. We're going to have the I for index pointer. That'll be blue. I. Next we have our mid pointer, which will be gray. And last we have our end pointer, which is also an argument passed in here. And that will be this kind of clay orangey color. Okay. So instead of trying to explain what Quicksort does at a high level, let's just step through the code. And as you watch the pointers move, maybe you'll kind of get a feeling of how it operates. So of course, we're starting down here. And so our start is at 0. Our end is on the last item. Now we can jump into kind of our recursive function up here, where I is also, of course, starting at 0. It's starting at start, so it will start at 0. And we also have mid, which is set equal to start in the beginning. So that is also on the first item in the array. Okay. Let's just start kind of iterating through what this traverse function does. So we're at this for loop for I in start.end. I'm sorry, start to almost the end, not including the end. We do our first check. If the item at index I is smaller than array end, we do a swap. So is 100 smaller than 9? It is not. So we're gonna move I to the next item. I put these two close together. We're now at 40. We're back at this on the right side here with this is I less than end if check, and it is not. So we're gonna increase I again, and we're now at 0. Is array of I less than array of end? It is. 0 is less than 9, obviously. And so now we swap the item at I with mid. So we're going to swap 0 with 100. And then we increase the mid pointer. Increase mid to 40. Okay, and then also I's going to go to the next item. Is array of I less than end? It is again. 3 is of course less than 9, and so we're going to do another swap. We're going to swap 3 with 40 because we're swapping I with mid, and then we're going to increase the mid pointer. I'm going to take a second here to rewrite that 100 because it's kind of big. Okay. And I need to increase my mid pointer because it's made a swap. And recenter my 40 to be a little bit better. Okay, now we move I forward again. And 2 is less than 9, so we're gonna do, again, we're gonna swap between mid and I. And then I need to remember to increase mid. I always forget that step. So do a little swap. And then increase I. And now we're at start is 1 less than end. So this for loop is finished, and we do a final swap between the mid and the end. We're now down at this step. Our mid is our gray and end is our orange. So we do a swap here between 9 and 40. And now we do, and now we go into our recursive steps. An interesting point that nobody else ever pointed out to me is 9 was our pivot, and 9 is now in its correct spot in the array. So, if we, of course, the actual correct order for this array is 2, 3, 9, 40, 100. And so 9 is in the 0, 1, 2, the 3 index. And also at this point in our yet unsorted array, 9 is also in the 3 index. And that's not a coincidence. Your pivot at the end of that for loop and the swap, your pivot will be in its correct position in the ending array. That's not something I ever understood before. And then something that other Quicksort videos will point out is now all of the items to the left of our pivot are less than the pivot, and all of our items to the right are larger than the pivot. That point has not been super intuitive to me. Okay, now we do our 2 recursive calls. We do our left recursive call, which is from start to mid minus 1. So that should be 0, 3, and 2. And then we have our right recursive call, which is mid plus 1, and the end, so that's just 140. We'll go in the same order as the compiler. So we are now back up at this step with our left call on the tree, which is our 0, 3, 2 array. Let's reset up our pointers. I is at 0, start is at 0, mid is at 0, and end is at 2. Okay, now let's go through this. We're going to go through our divide method just the same. So is the item at I less than end? It is. 0 is less than 2. And so we do the swap with mid. Mid is at the exact same place as start. As I. So we do a swap, nothing happens except that the mid pointer also increases. So that's important. Even though we swap, we basically just did a swap. We swapped 0 with 0, and we put it back in the same place. The important part here is we also increased our mid pointer. So now we're at I is equal to 1. Is 3 less than 2? It is not. So we now conclude this for loop. We're now down at this step, and we do a swap with our mid and our end. So our mid is at 3 and our end is at 2. Boom. This subarray is now sorted. I don't think the Quicksort knows that yet, but we'll come back to it. So this subarray is sorted, but first, before we kind of go down this tree of dividing it, let's handle the right tree, the 140. I had to light my face back up. Okay, let's set up our pointers for 140. Start is at 100. That is not the right tool. Start is at, oh, Jesus Christ. Start is at 100. I is also at 100. And mid is also at 100. End is at 40. Let's go through the same steps. We're going through this for loop. Is 100 less than 40? It is not. We're just going to skip to that for loop. We only have one iteration from start to end here, and nothing happens. 100 is greater than 40, except, again, we get down to our little swap here, and we swap 40 with 100, and this subarray is now sorted. I'm saying subarray. It's an array slice. A subarray maybe implies that it's a separate array. This is, of course, the benefit of Quicksort is that it operates in place. And so this is, in Swift, it maybe you're operating on an array slice or something like that. This is now sorted. Let's go back to our 0, 2, 3 array over here. Let's go back to this bad boy. So now, on this subarray, we need to do our two recursive methods. So we are going to do our left recursive call, which is start as a start of 1 and a end of mid, which is 1 minus 1, which would be 0. And good thing we have this check here if we only continue if start is greater than or equal to end. So in this case, end is less than start, and that means we're done here. So we're not going to continue any longer. Now we have our right recursive call. And our right recursive call start is at mid plus 1, which would be right here. Mid plus 1 is 2, and end stays the same. And it's also 2. Our check up here is if start is greater than or equal to end, and in this case it is equal. So we're also done here. I suspect we're gonna have a similar kind of set of checks for a right subarray now. So let's do these same recursive calls for our right subarray. We'll set our start is just start, which is 0. Okay, I realize kind of a mistake here. It's not actually 0. It'll be what its real index is in the greater array. So that's 0, 1, 2, 3, 4. So this is 4. End is mid minus 1, which will be 3. So that's another 1. That means that we're going to return on here and we're done. Now let's do our right recursive case. And I believe it'll be the same thing. Our start is going to be mid plus 1, which will be 5. And our end is also 5. And we are done. So our array is now fully sorted. Sorry. Well, if you combine our subarray here, our subarray here, and then our very first pivot, then you'll get an ending array of 0, 2, 3, 9, 40, 100. So I didn't discuss any of the other things you might learn about Quicksort in other videos, like it's a non-stable sort, it's faster than merge sort, but in worst case, it's n squared. There's a bunch of other kind of random facts you'll learn. This is focused on kind of the intuition of what it actually looks like under the hood if you could visualize the numbers. So I hope it helped.